So in our other examples, we looked at just triangles. So the orientation of the triangle did not matter. So, but what happens when we put it in a coordinate plane? So take a second and see if you can answer some of these questions. So let's look at this triangle here on this coordinate plane through the point 3, 4. So what does it mean when this point is at 3, 4? So this leg right here, this distance of this leg is going to be a 3. So it's 3 units, and this is going to be 4 units. So what does that make the hypotenuse? So 3 squared plus 4 squared, square root of that. So my hypotenuse is going to be a 5. Okay. So think about that. So your hypotenuse squared is going to be equal to your x squared plus your y squared. So now remember, I told you all these values when you took the square roots were always going to be positive. That's not always going to be the case. Okay, so if I wanted to find sine of theta, so sine of that angle theta is going to be your opposite side. So it's going to be 4 over your hypotenuse side. Cosine of theta is going to be the adjacent side, so it's the one, the x, so it's going to be 3 over a 5. And then tangent is going to be your opposite over your adjacent, so it's going to be 4 over 3. So what does that mean? So think about this in terms of x and y. So that means that sine is going to be your opposite over your hypotenuse. So that means that it's going to be your y over your h. Your cosine is going to be your adjacent side, so it's going to be x over h. And your tangent is going to be opposite over adjacent, so that's going to be y over x. Okay. All right, so before we go to the next question, let's think about this for a second. So the coordinate system, we have, this is my quadrant 1, right? So our x values are positive and our y values are positive. Remember, it goes then counterclockwise, so then this one is quadrant 2. Your x values are negative, but your y values are positive. In quadrant 3, here, your x and your y values are negative. In quadrant 4, your x values are positive, but your y values are negative. Okay, so we'll be talking about that in terms of our ratios in just a second. All right, so what about if we draw the point -3, 4? So -3, 4. So instead, we're going to go this way. So 1, 2, 3, -3, 1, 2, 3, 4. So it's going to be right here. Okay, so create a triangle such that hypotenuse is from the origin. So my hypotenuse is from the origin. And then my leg goes and makes a right triangle with the x-axis. Okay, so this is a right angle here. So let's call this, I think in the next one we talk about alpha. So let's call this my angle alpha that it creates there. So what are the lengths of the legs and the hypotenuse of this triangle? So this leg is going to be, so -3. So it is a -3 distance because I'm on the -3 side of the x-axis. And then it's still going to be a +4. And then my hypotenuse is still going to be a 5. Okay. So if I wanted to find sine of that alpha, so that's going to be my alpha. So sine of that alpha is going to be your opposite, so it's going to be 4 over your hypotenuse, which is a 5. Your cosine of alpha is going to be your adjacent, so it's going to be a -3 over your hypotenuse, which is a 5. And then tangent of alpha is going to be your opposite over your adjacent, so this is going to be a negative. So what happened to these ratios? So they're the same values except for now I've got negatives. So when I'm in quadrant 2, the only one of these ratios that is going to be positive is going to be sine, right? Because sine of alpha there is going to be positive. So the only thing that's going to be, so sine of theta will be positive. all will be positive in quadrant 1, right? So they were all positive in quadrant 1. All right, so let's look at this one. So question number 5 says, suppose that tangent of beta is equal to -4/3 for a triangle through a point in quadrant 4. So let's think about this. What is going to be the point if I'm going to be in quadrant 4? So quadrant 4, so this is tangent, so tangent of beta. Okay, so what did I say that tangent was? It's going to be y/x, right? So y/x. So my x value is going to be 3 and my y value is going to be 4. But does that make sense? There's a negative right here because it's got to be in quadrant 4 here. So what did we say? In quadrant 4, which one is going to be the negative? So which one's going to be the negative is going to be the y value. So I'm going to make the 4 be the negative. So let's go and draw it right here. So it's going to be 3, but I'm going to go down 1, 2, 3, 4. So -4 down here. Okay. Oh, terrible straight line, sorry. So this is going to be a -4. And this is still going to be a +5 because that hypotenuse is always going to be positive. So now this is going to be my angle beta right there, inside there, between the hypotenuse and the x-axis is going to be that angle. Okay. All right, so how can I find then sine? So sine of that beta is going to be your opposite, so it's going to be -4/5. And then cosine of beta is going to be 3/5, and it's positive. So what do you notice about quadrant 4? So which one is going to be positive? The ratios here. So the only one that's going to be positive is going to be your cosine. So in quadrant 4, cosine is the only one that's going to be positive. They're all going to be positive. So in quadrant 3, think about it. So the ratio of a negative over a negative, so that one would be tangent. So tangent of theta is the only one that would be positive there. Good. All right, so let's now define that in terms of coordinate system. So standard position just means that the angle, anytime it says standard position, the angle is opening from the x-axis and opening counterclockwise. Okay, so it's going to open along the x-axis. Let's just say, so here's my angle. So it's opening along the x-axis to this side, and this is my terminal side. Okay, so this is considered my terminal side of an angle. But when we draw our triangles to create, let's do this, we always go to the x. We make our right triangle with the x-axis. Okay. So this is our angle that we will reference in our right triangle. So we now will be in terms of x, y, and we call it r. So our r is now our hypotenuse, so almost like a radius. Okay, so r is for our radius. So so remember hypotenuse squared, so x squared plus y squared. So now we're going to turn it into r. Okay. All right, so sine of theta is still going to be your opposite over your hypotenuse. So in our terms, it will be y over your r. Cosine of theta is going to be your adjacent over your hypotenuse, and then tangent will be your opposite over adjacent. Right, and then we've got our reciprocal functions. So cosecant of theta is the reciprocal of sine, so this is going to be r over y. Secant of theta is going to be now, whoops, not x, sorry. R over x. Cotangent of theta is going to be x over y. Alright, so remember our values. So we've got quadrant 1, sorry I'm putting a lot of stuff up here. So quadrant 2, quadrant 3, and then quadrant 4. So think about your terms of your x's and your y values, and then what we would choose for our signs. Up here in quadrant 2, it's a negative and a positive. In quadrant 1, they're both positive. This is called your reference angle. So your reference angle to that triangle. Alright, so take a second and try to do this independent practice. Okay. So just take a second and work those two. Alright, so I'm going to go ahead and just do the A1 with you and then let you finish the other 3. And then that's what you'll upload these notes for me for attendance. So if you wanted to plot this point, so it's 4, -4, so that's going to end in quadrant 4. So it's opening, and this is going to be my terminal side, but my triangle, the right triangle, is always on the x-axis, so it's secured on that x-axis, so that's where it lies. So I need to find first the hypotenuse. So what is that? 4 square roots of 2. So this will be 4 square roots of 2. So now sine of theta. So sine of theta is going to be opposite. So it's going to be -4 over 4 square roots of 2. Cosine of theta will be your adjacent. So it's going to be 4 over 4 square roots of 2. Tangent of theta will be -4 over 4. So what is the simplified 2? So this is going to be a -1 over square roots of 2. We don't like square roots in the denominator, so we rationalize it. So we multiply both the numerator and the denominator by square roots of 2. So this ends up being negative square roots of 2 over 2. Same thing here, so we have 1 over square roots of 2. Multiply both the numerator and the denominator by square roots of 2. So you end up with a positive square roots of 2 over 2. And this is just a -1. Okay. Alright, so I want you to find do B and number 2 for me. If you need anything, let me know.